What is the total internal energy of a system? In the system, there is the two different type of gases are present at a temperature T. It's known that the total internal energy or else the internal energy for an ideal gas can be expressed using a formula U is equal F divided by 2 times nRT, whereas F is representing the number of degrees of freedom of the gas molecule, whereas N is representing the number of moles and R is representing the universal gas constant and T is representing the temperature. In the given system, there is the two different gases. So here we can write the total internal energy of a system is the sum of the internal energy of oxygen and the internal energy of argon atom. So here we can apply the formula. So the total internal energy will be F over 2 times nRT for oxygen atom plus F over 2 times nRT for the argon atom. It's known that the degrees of freedom of oxygen atom is nothing but 5 because it is a diatomic molecule. Whereas the degrees of freedom for an argon atom is 3 because it is a monoatomic molecule. So, because it is monoatomic. So here we can apply the value UT will be equal to 5 divided by 2 times N is representing the number of moles of oxygen which is given as 2 in the question. So 2 times R. We are not applying the R value here because in the answer option everything is having R. Whereas temperature is given as T, so we are just applying T plus 3 divided by 2 and the number of moles of argon is given as 4. So 4 times RT. When we are simplifying this, we will get the answer of 11 RT. So this is a value of total internal energy. So the correct answer here is option C.